Hello everyone. In this lecture we are discussing evaluation of triple integral using given region. In first lecture we have already seen type 1 region, that is if region is bounded by sphere. Now here we are discussing type 2 region, that is if region is bounded by cylinder or cone or paraboloid. And we know that sometimes it is not easy to find the value of triple integral using Cartesian coordinates only. So that time generally we are converting this Cartesian coordinate system into the polar coordinate system, and after that we are evaluating triple integral. So here also if region is bounded by cylinder or cone or paraboloid, then that times we are using polar coordinate system, and for this we are generally taking this standard substitution, and the substitution is we have to replace x by r cos theta, y by r sin theta, and z by itself, that is z, and dx dy into dz by r dr d theta into dz. So this substitution is only applicable for if region is given or region is bounded by cylinder or cone or paraboloid. So this system or this substitution is also called as a cylindrical coordinate system. So using that substitution, now we are solving one example, and the example is evaluate triple integral of square root of x square plus y square dx into dy into dz over the volume bounded by the right circular cone x square plus y square equals to z square, where z is greater than 0, and the planes z equals to 0 and z equals to 1. So here we have to find this value of this triple integral. Now first of all we are writing our given region of integration. So first of all I am writing given region of integration is bounded by the given region, that is x square plus y square equals to z square, that is nothing but equation of cone where z is positive, and also we have provided another region, that is both the equation of planes, that is z equals to 0 and z equals to 1. So now to find or to evaluate this triple integral, we have to convert this Cartesian coordinate system into the polar coordinate system. So for this we are using a cylindrical coordinate system. So for this, firstly we transform this given integral to the cylindrical coordinate system by putting x equals to r cos theta, y equals to r sin theta, z equals to z, and dx dy dz equals to r dr d theta dz. So using that substitution we are converting our given region of integration into the polar coordinate system. So first of all we are taking x square plus y square equals to z square, that is equation of cone, and after substituting these values we'll get r cos theta its bracket square plus r sin theta its bracket square equals to z square. And if I take r square common at RHS side, so in the bracket only cos square theta plus sin square theta is remain, and value of this is 1, so only r square is remain at LHS side, so this becomes r square equals to z square. And from another two equation, that is z equals to 0 and z equals to 1, it will be as it is because we are generally replacing z by itself, so this two equation will be as it is. Now we are observing this figure, and this figure is drawn from these three equations. So here you can observe this is the cylinder, and this above plane is nothing but z equals to 0, and this z equals to 0 plane, that means only xy plane. So using that we are finding now limits. So here we can observe these three polar equations. In that three polar equation z is present, that is r square equals to z square, z equals to 0 and z equals to 1. All are the equation in the polar form. So firstly we are finding limits for z. So here you can observe this first equation, that is r square equals to z square. From that we are getting two equation, that is z equals to r and z equals to minus r, but we are considering a positive quadrant, so we are considering only z equals to r. And here from these two equation, z equals to 0 and z equals to 1, z equals to 1 is the upper bound, so our radius is starting from r and ending at z equals to 1. Here we cannot take z equals to 0 is a lower limit because our radius is varying, and which is depends on that first equation of polar form, so that we have to take our lower limit is z equals to r and upper limit is z equals to 1. So here I am writing z varies from z equals to r to z equals to 1. Now we have to vary our r, and we know that r is nothing but a radius, and radius is always starting from this origin, means from that figure here radius is starting from that origin. So here r is varies from 0 and ending at this plane. So here your radius is r equals to 1. So r varies from r equals to 0 to r equals to 1. And here you can observe this cylinder is moving in whole plane. So your theta is varies from theta equals to 0 to theta equals to 2 pi. So these are the limits of z, r and theta. Now depending on that limits we are finding or evaluating this integral. Therefore this given triple integral can be written as I equals to triple integral of x square plus y square dx dy dz that we have provided. Now we have already find the limits of r, theta and z, so we are using that limits. So here the first limit I have taken, theta is varies from 0 to 2 pi, r is varies from 0 to 1, z is varies from r to 1. Now we have to change our Cartesian coordinate system into the polar, so that I am putting here r cos theta instead of x and r sin theta instead of y. So we'll get this square root of r cos theta its bracket square plus r sin theta its bracket square into, we are replacing dx dy dz by r dr d theta into dz. So according to that integral with respect to z, r and theta, we are taking this r dz into dr into d theta. So now in the next step we are evaluating this. So after taking r square common, we'll get only cos square theta plus sin square theta is remain in the bracket, and its value is 1. So r square and its square root is nothing but only r, and this 1r and this r is nothing but r square. So here only r square is there. So first of all we are taking integration with respect to z, because upper limit or lower limit of this inside integral is the function of r. So first of all we are taking integration with respect to z, so that times this r square will be constant and the integration of this will be only z, and upper limit z equals to 1 and lower limit z equals to r is as it is. So after putting upper limit and lower limit, we'll get r square minus r cube, because of after multiplying this r square to inside that bracket. So here 1 minus r is there only, and after multiplying this r square to inside the bracket, it will get r square minus r cube. Now we are taking integration of this with respect to r. Now here integration of r square with respect to r is r cube upon 3, and integration of r cube is r raised to 4 upon 4. So after putting upper limit and lower limit, that is r equals to 1 and r equals to 0, we'll get 1 by 3 minus 1 by 4 only. So calculation of this is nothing but 1 by 12. Now here only 1 is remained, so integration of this with respect to theta is only theta, and after putting this upper limit, that is theta equals to 2 pi and theta equals to 0, we'll get 2 pi. So 1 upon 12 into 2 pi, that is pi by 6, and that is our final answer.